Hello and welcome to all to this lecture series on basic thermodynamics. This is lecture 1, Introduction and Basic Concepts. So let us start. First of all, we need to know what is thermodynamics. Thermodynamics is a branch of science which deals with energy transfer and its effect on properties of the substance. The properties can be physical properties as well as the chemical properties. The amount of heat or work transfer taking place while arriving at one state from another is the main concern in thermodynamics. That means that how much amount of heat transfer has taken place or how much amount of work transfer has taken place while arriving at one state from another is the main concern in thermodynamics in terms of energy, joule, kilojoule, etc. Okay, then we have two important terms known as system and surroundings. What are those? System. See, what is a system? It is a fixed mass or region in a space, that is control volume, where our study is focused. Basically, it is that part of the universe where our study is focused. Okay, then we have another term that is known as surrounding. Everything external to the system is known as surrounding. Okay, and that part of the surrounding which is affected by the system is known as immediate surrounding. Okay, I hope this is clear. Let us move. We have classified systems into three categories. One is closed system, one is open system, and third one is isolated system. What are those? Have a look at them. Closed system. It is a type of system in which only energy interaction and no mass interaction take place. Okay. Simple example is piston cylinder arrangement without valves. Means no mass can enter or no mass can leave the system. However, energy can enter or energy can leave the system. That is a closed system. Then we have an open system. What is it? It is a type of system in which both energy and mass interactions take place. Means energy and mass can enter into the system and also can leave the system. That is known as open system. Example is piston cylinder arrangement with valves. Then we have third category, isolated system. What is it? It is a type of system in which neither energy nor mass interaction. Neither energy nor mass interactions. Okay. Example is hot coffee or tea kept in a well insulated thermos flask. Means when the hot coffee or tea is kept in a well insulated thermos flask, neither energy nor mass interactions takes place and that hot fluid remains at a relatively hotter temperature for a very long period of time. But please let me make it clear that ideally that thermos flask cannot be considered as a isolated system, because after some point of time it will lose some heat and eventually that hot fluid will become normal. Okay, so that thermos flask can not be considered as a completely isolated system. Okay, it is somewhat isolated but not completely isolated. However, there is one more example, that is universe. The whole universe is an isolated system. How it is, we will see it in the further lectures. Okay, then we have boundary. We have system and the surrounding, and the part or the surface which separates them is known as boundary. It can be a real or imaginary, or it can also be fixed and movable. How it is? Let us see. See, this is a piston cylinder arrangement. This is a cylinder which is fixed and this is a piston which is movable. Okay, if we draw inside this control volume this boundary, so the boundary which is near to this cylinder is a fixed boundary. Okay, on the other hand, the boundary which is close to this piston, this is a movable boundary. When this piston will move up or move down, then this boundary which is close to this piston will also move up and down. So this is basically a movable boundary, whereas these boundaries which are near to this piston, near to this cylinder, they are fixed boundaries. Okay, on the other hand, this is basically a schematic diagram representation of a compressor. this is the inlet, this is the outlet, and if this is our control volume, and if we draw the boundary inside this control volume, we will see that this boundary and this boundary is a real boundary, okay, and on the other hand this boundary and this boundary is an imaginary boundary. So I hope from these both figures you clearly get the concept of real or imaginary surface, or also the fixed or movable surface. Okay, let us move on further. What is a property of a system? Any characteristic of a system is known as the property. The characteristic can be pressure, temperature, volume, enthalpy, entropy, anything. Any characteristic of a system is known as the property of the system. Okay, then we have classified those properties into two categories, extensive and intensive. What are those? Intensive, also called as intrinsic properties. What are those? Properties which are independent of the mass of the system. Example, density, temperature, pressure, etc. Okay, these are known as intensive properties. And another classification is extensive or extrinsic properties. What are those? Which are dependent on the mass of the system. They are known as extensive or extrinsic properties. Example, volume, enthalpy, entropy, kinetic energy, potential energy, and many more. Okay, and all the specific properties are intensive or intrinsic properties. What does this mean? What is a specific property? Any property per unit mass is known as a specific property. Any property per unit mass is known as a specific property, and when we consider any property per unit mass, that means it becomes independent of mass. So all the specific properties are intensive or intrinsic properties. Example, specific volume, specific enthalpy, specific entropy, etc. Okay, then how to find out whether any given property of the system is intensive or extrinsic? Okay, how to find out? See, we have a system in which we have a substance having mass m, volume v, temperature T, pressure P, and density rho, and we divide that system by making a partition. Then we note that the mass in each section gets half, volume gets half, and temperature, pressure, and density remains same. So the properties which reduces on partitioning of the system are known as mass dependent properties or extensive properties. On the other hand, the properties which remains same even after the partition, they are known as mass independent properties or intensive properties. I hope this concept is very clear to you. Okay, then we have some key points with respect to properties. What are those? They are point functions. Point functions mean they just depend upon the final position and the initial position, okay, or the final point or the initial point. They are not influenced by the path what we consider while going from initial position to final position. Okay, they are exact differentials, means their value is the difference of their values at the final position and the initial position. Okay, and they are independent of the past history. That means that their values of the properties are not influenced by the past. Means if we consider any property, we consider any value of any property at any point in a system, so that does not that is not influenced by what was its property 2 hours or 3 hours before or 10 days before. We are not really concerned with it because it is independent of past history. Okay, then we have state. What is it? Any condition of the system is known as the state of the system. Okay, any condition means we have some specified pressure, volume, temperature, anything we have specified, that becomes a system. Okay, and what is a process? It is a change of state, is called process. We change any one property of the system and that becomes another state, Okay, and that change of state is known as process. And what is the process path? The infinite states through which the system passes while going from initial state to the final state is called the process path. We have state 1 and we have state 2, and the infinite states through which the system passes while going from initial to final state is known as the process path. The process path can be constant pressure path, constant volume path, constant temperature path, okay, adiabatic path, anything can be there. That would be specified what is the path. But the infinite states through which the system passes while going from initial to final state is known as process path. Okay, then we have classification of processes. Processes are broadly classified into two categories. What are those? Quasi-static and non-quasi-static, and reversible and irreversible. What is those? Quasi-static. It is that kind of a process that occurs infinitely slow. Means any process that is occurring infinitely slow, that is known as a quasi-static process, and they are represented by joined lines on the property diagrams. Okay, then non-quasi-static process, it is that kind of a process that does not occur infinitely slow. Okay, does not occur infinitely slow, that is non-quasi-static. Occurs infinitely slow, quasi-static, and they are represented by dashed lines on the property diagrams. Okay, then we have another classification, reversible and irreversible. What is those? It is a kind of process which can be reversed in direction following the same path and without leaving any effect on the system and the surroundings. So on observing this statement, you will find three conditions. What are those? Reversed in direction, following the same path, and without leaving any effect on the system and the surroundings. These are three conditions. If all these three conditions are satisfied, then only we will say that the process is a reversible process. Okay, so these three properties are reversed in direction, following the same path, and without leaving any effect on the system and the surroundings. If any of these three properties is violated, any one or two are violated or three are violated, then we say that the process is not reversible. Okay, so for the process to become reversible, all these three conditions need to be followed. Okay, then we have quasi-static. We have some important points. We have all the quasi-static processes are not reversible. Okay, please make it clear, this is not all the quasi-static processes are not reversible, but a reversible process is always quasi-static. A reversible process is always quasi-static. Means, what is quasi-static process? That occurs infinitely slow. If a process is occurring infinitely slow, that does not mean it is a reversible. For a process to be reversible, those three conditions which I have told you in the earlier slide, that needs to be followed. Okay, and if any process follows that three conditions, it becomes reversible, and it is always quasi-static. Okay, then quasi-static compression and expansion of a gas is reversible process. Okay, then we have macroscopic and microscopic analysis. What is those? Macroscopic analysis. In this analysis, average molecular behavior is taken into consideration. Okay, we will not take the individual molecular behavior, we will consider the average molecular behavior, how the molecules are behaving on a whole, on an average basis. That is our main concern in macroscopic analysis. Okay, and this approach is valid till the concept of continuum holds good. What is that? The mean free path of the molecules is very much less than the system dimensions. Okay, what is the mean free path of the molecule? Mean free path of the molecules means the distance traveled by the molecules between successive collisions, and if that distance traveled by the molecules between successive collisions is very much less than the system dimensions, so it is known as the concept of continuum is valid, and in that case we will consider the macroscopic analysis and the average molecular behavior will be taken into consideration. Okay, on the other hand, when the system becomes rare, that means when the mean free path of the molecules becomes of the order of the system dimensions, then the individual molecular behavior is taken into consideration, and that is known as microscopic analysis. And please make a note, properties like pressure, stress are valid only when the concept of continuum is valid, otherwise they are not valid. Okay, and in this case, when the system has become rare, we need to use another theory that is known as a rarefied gas theory. Okay, I think this is clear. Okay, now pressure, one very important property, pressure. What is it? What is the cause of pressure in gases? Pressure in gases is due to the forces occurring because of the colliding molecules with the surface, and it acts normal to the surface. Okay, pressure is a function of density and temperature. Okay, pressure is a function of density and temperature. What is density? Density is density is directly proportional to the number of molecules colliding. More the number of molecules colliding, more will be the density. Okay, and colliding velocity is directly proportional to temperature. Okay, see, according to kinetic theory of gases, this CRMS, that is root mean square velocity, is given by under root of 3RT by m, where R is the characteristic gas constant, T is the temperature, and m is the mass. Okay, and in liquid, the pressure in the liquid is due to repulsion between the molecules. In the liquid, there is repulsion between molecules, and due to that there exists pressure. Okay, then we have thermodynamic equilibrium. What is it? Thermodynamic equilibrium consists of four equilibriums. What are those? Thermal equilibrium, mechanical equilibrium, chemical equilibrium, and phase equilibrium. For the system to be in thermodynamic equilibrium or complete equilibrium, all those four, okay, please mind it, all these four must be satisfied. If any one of them is not satisfied, we cannot say that the system is in thermodynamic equilibrium. Okay, what is thermal equilibrium? Thermal equilibrium means equality of temperatures. If the temperatures are not equal, then there will be a heat flow. Okay, and there will be a heat flow within the system, and in that case we say that the system is not in thermal equilibrium. Okay, then mechanical equilibrium, that means equality of forces, or the forces arising due to pressures. Okay, that means the pressure should be same at each and every point of the system with time, means the pressure should not change with space, or the pressure should not change with time. If that condition is satisfied, we say that our system is under mechanical equilibrium. Okay, then we have chemical equilibrium. What is it? Chemical composition of the system should not change with time. That means within the system, chemical equations or chemical reactions should not take place. Okay, and if that condition is satisfied, we say that the system is under chemical equilibrium. Then what is phase equilibrium? Mass of each phase should remain constant with time. That means if a system is comprising of more than one phase, then mass of each phase should not change with time, or it should remain constant with time. If this condition is satisfied, we say that the system is under phase equilibrium. Okay, what is phase and all this? We have solid phase, liquid phase, vapor phase. These all we will consider in a later part of this lecture series, when we will consider about the properties of the pure substance. Okay, so that's it for this lecture. In the next lecture we will come up with thermometry, zeroth law of thermodynamics, and in the further lectures we will move on with first law and second law of thermodynamics. Okay, so thank you for watching this lecture and have a good day.